Welcome to this video on how to calculate a residual. After watching this video, you will be able to state the equation used to calculate residuals, state whether the linear equation is an overestimate or an underestimate of the actual value, and calculate the residual of a given data point. What is a residual? Think about the word residual in everyday life. What does it mean? Pause the video, write down your thoughts, and then unpause the video to see if you were correct. The word residual means what is left over. This is exactly what it means in statistics as well. When we create a line of best fit or a linear regression, there will be a slight discrepancy between the actual data value and the model predicted value. This difference is called the residual. More formally, we define the residual as observed minus predicted. The observed value is the data point, and the predicted value is the value predicted by the equation. Let's refer back to the blood alcohol content versus number of beers example we have used in many previous videos. Notice that almost none of the data points or blue dots lie exactly on the equation or the red line. The vertical distance between a blue dot and the red line is the residual. Notice that there will be a different residual for each data point. Here, this vertical yellow arrow is a visual representation of the residual for x equals 9 beers. Notice that for x equals 9 beers, the predicted value, which is the red line, lies below the actual data point or the blue dot. Therefore, in this example, the model is an underestimate of the true value. However, this is only true for this specific data point. For other data points, it might not be true. For x equals 8 beers, the predicted value, or the red line, is above the actual data point. Therefore, at this point, the model is overestimating the true value. Notice that some values of x, such as x equals 5, have multiple data points. Therefore, before you could calculate the residual at x equals 5, your instructor would have to specify which data point to use. Steps to calculating a residual. Remember, residual is the observed value minus the predicted value. The first thing you need to do is to find the observed y value, not the x value, by consulting the data set. Then, you find the predicted value by substituting the appropriate x value into the equation and solving for y. Lastly, you substitute both the observed value and the predicted value into the residual equation to find the residual. Remember, residual is observed minus predicted. Let's calculate the residual in our example for x equals 9 beers. The residual is the observed value minus the predicted value. First, we need to find the observed value. In order to find this exact blood alcohol content associated with this data point, I have to consult my data set. So remember, my data set is in StatCrunch. I'm going to go over to StatCrunch right now, and I'm going to find the data set or the data point for x equals 9. Here is my data set in StatCrunch. I'm going to look over here. This left side shows me the number of beers. Notice that when the number of beers is 9, the blood alcohol content of this person was 0.19. Therefore, this is the observed value that I'm going to capture and put into my equation. Let's go back to our PowerPoint presentation and put that value in. So we have our observed blood alcohol content value of 0.19. And remember, we found that by actually consulting our data set. Next, we need to find our predicted blood alcohol content value. And that's going to be the value over here on this red line. And the way we find that, remember, is by substituting the appropriate x value, in this case, 9 beers. We're going to put that into our equation and solve for y. When we do that, we find a blood alcohol content of 0.1493. So we have both our observed value and our predicted value. So to find our residual, we need to plug both of those values into the equation to find the difference between the two. So again, our observed value straight from our data set was 0.19. Our predicted value, based on this calculation, was 0.1493. And when we subtract them, we find a residual of 0.0407. Therefore, the residual for x equals 9 is a blood alcohol content of 0.0407. Note that a positive residual corresponds to an underestimate on the part of the linear equation. In other words, this linear model is lower than the actual data value. Now let's calculate the residual for x equals 8 beers. Remember, the residual is the observed minus the predicted value. Here's our graph, and as you can see, the blue dot represents the observed value at x equals 8, and we're going to have to go over to our data set to find the exact blood alcohol content, because just looking at this graph, it would just sort of be a guess. So let's jump over to our data set to see what the exact blood alcohol content is for the person who consumed 8 beers. Okay, here's our data set. So looking at the number of beers, you can see there is only one data point for the person who consumed 8 beers, and that person looks like has a blood alcohol content of 0.12. So this value 0.12 is going to be our observed value that we're going to put into our residual formula. Let's go back to our PowerPoint. So our observed blood alcohol content value is 0.12, and again we got that just from looking at our data set. Now we need to find our predicted blood alcohol content value, which is represented by this red line here. And remember, to do that, we need to substitute x equals 8 into the regression equation. So here's our regression equation that we found using StatCrunch. And we put in 8 in place of x, and we evaluate it. And putting that into a calculator, we have a predicted blood alcohol content of 0.1313. Now we have our observed and our predicted value. We can plug both of these values into our residual equation. And we find out that we actually have a negative residual this time, which is negative 0.0113. The residual for x equals 8 is a blood alcohol content of negative 0.0113. Note that this negative residual corresponds to an overestimate on the part of the linear equation. And we can see that visually, this red line, which is our predicted value, is above the data point, which means it overestimated the actual blood alcohol content. At this point, you should now be able to state the equation that is used to calculate residuals. Remember, the equation is that the residual equals observed minus predicted. You should be able to state whether the linear equation is an overestimate or an underestimate of the actual value. An easy way to do that is to simply look at your scatter plot with the line superimposed. Another way to think about it is to remember that a positive residual corresponds to an underestimate of the actual value, while a negative residual corresponds to an overestimate of the actual value. You should also be able to calculate the residual of any given data point. We do this in 3 steps. First, we find the observed value in the data set. Then, we find the predicted value by substituting the appropriate x value into the linear model and solving for y. And then lastly, we use the equation observed minus predicted to find the residual.